Hi guys, it's Joe here at Measurement Solutions. A few weeks ago we ran through a workflow that we did in collaboration with Ricoh, where we optimized some of their machine feet using nTopology. Today I just want to show you how repeatable and reusable that workflow is. So a quick recap on what we did last time. We brought in the CAD, applied a force face and a restraint face to give us our static analysis results. We used these results to drive the wall thickness of the part. We ran through another static analysis and used those results to drive the thickness of the gyroid structure. So we've got thicker gyroid in areas of high stress and thinner gyroid structure in areas of low stress. So this was the first foot. To repeat that same process on the second foot was relatively straightforward. We just go back to the top of the workflow, bring in our new part, and then we've got a few variables that we need to change in these blocks here. So we can take out our CAD body and force faces and replace them with the new CAD body, the new restraint face, and the new force face. Now in the background, nTopology is going to run through that exact same process that it did on the last part. It's going to run a static analysis of the initial part. And we're going to use the results of that static analysis to drive the wall thickness of the part. So we've followed it here. In this case, we had some slightly different stresses. So the wall thickness in the low stress areas was a bit too thin. We can quite easily change this by just changing it from a 2mm wall thickness in low stress areas, bumping it up to 4mm. nTopology is going to update that super quick and carry on going through the rest of the workflow. So it's now running a static analysis on that part, converting it into a gyroid, and giving us thicker wall sections in high stress areas and thinner walls in low stress areas. So what if we wanted to apply this to any other part? We can turn this whole workflow into a custom block. So I'm just going to drag in a few variables that we might want to change when we're using this workflow on other parts. We need a CAD body, some restraint faces, load faces, and variables to change the wall thicknesses of the shell and of the gyroid structure. The last thing to do is drag the final part into the output, and I can save it as a custom block. Now if I start a new instance of nTop, I can import any part I like. In this case, I'm going to bring in this bracket. The first thing I'm going to do is apply some restraint faces. So I'm just going to drag these out as a CAD face list. Now I can import my custom block and just populate the custom block with a CAD body, the restraint faces that we just created, and a force face. In this case, the orientation is slightly different, so I'm having to change this force face. We've sped up the process of how quickly this can create, but if we see the drop down here, that took 24 seconds in real time to create this really complex structure. Now if we look in the cross section, we can see that we've got thicker walls in high stress areas, thinner in low stress areas. This part's a little bit smaller, so I'm going to change the wall thicknesses slightly. And again, nTopology is going to run through that workflow. 24 seconds later, we have a new part with thicker walls in high stress areas and thinner in low stress areas. So if you want to see these parts in the flesh, then please feel free to join us for the Ricoh Open Day on December the 8th. Otherwise, if you can't wait that long, we're also going to be at the MTC for the Made for Space event on November 22nd, 23rd. And of course, I'll be at Formnext next week. I'm there Tuesday, Wednesday, and Thursday. So if you want to see a live demo of nTopology, or if you want to catch up at any of these events, then please feel free to give me a shout and let me know. Cheers.